At the end of this topic, you will be able to define solution, differentiate solute and solvent, define binary solution, define homogeneous mixture. Solutions are of great importance in everyday life. For example, the process of food assimilation by man is in the form of solution. Blood and lymph are in the form of solution to decide the physiological activity of human beings. Salt water, syrup, sugar in water, shampoo, soaps dissolved in water, vinegar, acetic acid in water are used in the form of solution in our everyday life. A solution is a mixture of two or more substances in a single phase. One constituent is regarded as solvent and the other as solutes. All solutions exist in homogeneous form. Homo means the same. It has the same uniform appearance and composition throughout. Maintain one phase, solid, liquid, and gas. If a solution contains two components, it is called a binary solution. Salt solution containing common salt and water is a suitable example for binary solution. A solid is a solid that is dissolved in a liquid. A solvent is a liquid in which something is dissolved in. In a solution, the component present in lesser amount by the weight is called solute. The component present in a larger amount by weight is called solvent. Solvent surrounds the particles of solute to form solution. A solution can be represented. Solute plus solvent gives solution. In this topic, you have learnt a solution is a homogeneous mixture of two or more substances. Homogeneous refers to the state in which two or more substances are uniformly present in a given mixture. If a solution contains two components, then it is called as a binary solution. The component present in lesser amount by weight is called solute. The component present in a larger amount by weight is called solvent. Solute plus solvent gives solution. At the end of this topic, you will be able to classify the solution based on particle size, classify the solution based on solvent, classify the solution based on amount of solute, classify the solution based on the physical state, explain Tyndall Effect, explain Brownian movement, describe the properties of true colloidal solution and suspension. Solutions are the homogeneous mixture of two or more substances. They are classified based on particle size, solvent, and solute. Based on the particle size of the substance, solutions are of three types: true solution, colloidal solution, and suspensions. A true solution is a homogeneous mixture that contains small solute particles dissolved in the solvent. Example, sugar in water. Colloidal solution is a heterogeneous mixture of two phases, namely dispersed phase and dispersion medium. Dispersed phase plus dispersed medium gives colloidal solution. The substance distributed as particles are called dispersed phase. The continuous phase in which the colloidal particles are dispersed is called dispersion medium. Suspensions are a heterogeneous mixture of insoluble particles in a solvent. Example, chalk powder in water. The phenomenon by which colloidal particles scatter light is called the Tyndall Effect. If a beam of light is allowed to pass through a true solution, some of the light will be absorbed and some will be transmitted. The particles in true solution are not large enough to scatter the light. However, if light is passed through a colloid, the light is scattered by the larger colloidal particles and the beams become visible. This effect is called Tyndall Effect.
Click on the animation button to view the animation.
Observe and take a picture of the scattering of light when sunlight passes through the window of the classrooms. The dust particles scatter the light, making the path of the light visible. Brownian movement is named in honor of Robert Brown, a biologist. He observed the motion of the particles in suspension of pollen grains in water. The phenomenon by which the colloidal particles are in continuous random motion is called Brownian movement.
Click on the animation button to view the animation.
Comparing the properties of true solution, colloidal solution, and a suspension. Particle size A. 1 ampere is equal to 10. True solution 1A to 10A. Colloidal solution 1A to 2000A. Suspension more than 2000A. Appearance. True solution is transparent. Colloidal solution is translucent. Suspension is opaque. Visibility of particles. In true solution, it is not visible even under ultramicroscope. In colloidal solution, it is visible under ultramicroscope. In suspension, it is visible to the naked eye. Nature. True solution is homogeneous. Colloidal solution is heterogeneous. Suspension is heterogeneous. Diffusion of particles. True solution diffuses rapidly. Colloidal solution diffuses slowly. Suspension diffusion does not occur. Scattering effect. True solution does not scatter light. Colloidal solution scatters light. Suspension does not scatter light. Based on the type of solvent, solutions are classified into two types: aqueous solution, non-aqueous solution. The solution in which water acts as a solvent is called aqueous solution. Example, sugar solution. The solution in which any liquid other than water acts as a solvent is called non-aqueous solution. Example, sulfur and carbon disulfide, benzene, ether, CS2 are some of the examples of non-aqueous solvents. Based on the amount of solute and the given amount of solvent, solutions are classified into three types: saturated solution, unsaturated solution, and supersaturated solution. A solution which contains the solute in a lesser amount in comparison with the solvent is called unsaturated solution. In this, addition of solute is possible till the solution reaches the point of saturation. Example, 5 grams or 10 grams or 20 grams of NaCl in 100 ml of water. In a solution, if no more solute can be dissolved in a definite amount of solvent at a given temperature is called a saturated solution. Example, CO2 in water. 36 grams of NaCl and 100 grams of water at room temperature form saturated solution. Nitrogen in earth soil is an example for saturated solution in nature. Earth soil cannot store more N2 than it can hold. In a solution, if more of solute at a given temperature than that of saturated solution is called supersaturated solution. Test whether a solution is saturated, unsaturated, or supersaturated with respect to the addition of salt at a particular temperature to the solution. Materials required: glass, salts 20 grams, 16 grams, and 1 gram packets, tablespoon, water. Procedure: take a glass containing 100 ml of water, weigh 20 grams, 60 grams, and 1 gram of salt and make 3 packets. Add the salt of weight 20 grams to the glass. Stir it with tablespoon. Record your observation. Add the salt of weight 16 grams to the same glass. Stir it with a tablespoon. Record your observation. Repeat the same with the third packet and record your observation. Record your observations. The observations are: 20 grams. Observation: the substance dissolves. Type of solution: unsaturated solution. Reason: the solute is lesser in amount than the solvent. Amount of salt: 16 grams. Observation: the substance dissolves. Type of solution: saturated solution. Reason: 20 plus 16 is equal to 36 grams of salt in 100 ml of water. No more amount of solute can be dissolved in a definite amount of solvent. Amount of salt: 1 gram. Observation: the substance dissolves. Type of solution: supersaturated solution. Reason: it contains more of solutes than saturated solution. Based on the physical state of the solute and the solvent, solutions are of 9 types. They are: solute solid and the solvent is solid. Examples: alloys. Solute is solid and the solvent liquid. Examples: sugar solution. Solute solid, solvent gas. Example: smoke. Solute liquid, solvent solid. Example: cheese. Solute liquid, solvent liquid. Example: milk. Solute liquid, solvent gas. Example: cloud. Solute gas, solvent solid. Example: cork. Solute gas, solvent liquid. Example: soda water. Solute gas, solvent gas. Helium-oxygen mixture for deep-sea diving. In this topic, you have learned, based on the particle size of the substance, the solutions are divided into 3 types: true solution, colloidal solution, and suspensions. The phenomenon by which colloidal particles scatter light is called the Tyndall Effect. The phenomenon by which the colloidal particles are in continuous random motion is called Brownian movement. Based on the type of solvent, solutions are classified into 2 types: aqueous and non-aqueous solution. Based on the amount of solute in the given number of solvents, solutions are classified into the following types: saturated, unsaturated, and supersaturated solution. Nitrogen in earth soil is an example for saturated solution. At the end of this topic, you will be able to define solubility of a solute in a solvent, define dilute and concentrated solutions, list the factors affecting the solubility, determine the solubility of a solid, state Henry's law, calculate the solubility of a solid. Solubility of a solute in a given solvent at a particular temperature is defined as the number of grams of solute necessary to saturate 100 grams of the solvent at that temperature. For example, solubility of CuSO4 in H2O is 20.7 grams at 20 degrees Celsius. Concentration of a solution is the amount of solute dissolved in a given amount of solvent. A solution containing less amount of solute is known as dilute solution. A solution containing large amount of solute is known as concentrated solution. The solubility of any solid can be determined using the formula solubility is equal to weight of the solid substance into 100 by weight of the solvent. 100 ml of water can dissolve 36 grams of NaCl at 25 degrees Celsius to attain saturation. Solubility of some ionic compounds at 25 degrees Celsius are given in the table. NaCl 36 grams. NaBr 95 grams, NaI 184 grams, NaNO3 92 grams. Determine the solubility of KCl in water at room temperature. Materials required: KCl, water, funnel, filter paper, thermometer, burner, evaporating dish, and desiccator. Procedure: prepare standard solution of KCl in about 30 ml of water at room temperature. Take few amount of KCl and add to 30 ml of water in a beaker. Dissolve it. Add more of KCl, ensuring that solution is saturated and some KCl is left undissolved. Take a dish and weigh it. Find the solution in the dish to remove solid KCl using funnel. Weigh the dish containing saturated solution of KCl. Find temperature of the solution by dipping a thermometer in it. Evaporate the solution to dryness by using a low flame to avoid bumping. Allow the dish and solid to cool to room temperature. Place the dish and solid in a desiccator containing anhydrous calcium chloride. Calcium chloride is a dehydrating agent. It absorbs moisture. Weigh the dish containing dry KCl. Note down the weights. The observations are: weight of the dish W grams is equal to weight of the dish plus saturated solution of KCl W1 g grams is equal to weight of dish plus dry KCl W2 grams is equal to. Calculations: weight of saturated solution is equal to W1 minus W grams. Weight of KCl is equal to W2 minus W grams. Weight of water present in saturated solution is equal to W1 minus W minus W2 minus W grams is equal to W1 minus W2 grams. Substitute all the values and determine the solubility of KCl using the formula. Solubility of KCl is equal to weight of KCl into 100 by weight of solvent. Solubility of KCl is equal to W2 minus W into 100 by W1 minus W2. Therefore, solubility of KCl is found to be -gram. The factors affecting solubility are temperature, nature of solute or solvent, and pressure. Effect of temperature. In endothermic process, solubility increases with increase in temperature. Example: solubility of KNO3 increases with the increase in temperature. In exothermic process, solubility decreases with increase in temperature. Example: solubility of CaO decreases with increase in temperature. Nature of solute or solvent. Solubility of a solute in a solvent depends on the nature of both solute and solvent. A polar compound dissolves in a polar solvent. Example: common salt dissolves in water. A polar compound is less soluble or insoluble in a non-polar solvent. Effects of pressure. Effect of pressure is observed only in the case of gases. An increase in pressure increases the solubility of a gas in a liquid. For example, CO2 gas is filled in soft drinks using the effect of pressure. Increase in pressure increases the solubility of gases. At a given temperature, the mass of gas dissolved in a fixed volume of liquid is directly proportional to the pressure of the gas on the surface of the liquid. This is called Henry's law. Take 10 grams of common salt and dissolve it in 40 grams of water. Find the concentration of solution in terms of weight percent. Solution: weight percent is equal to weight of the solute by weight of the solute plus weight of solvent into 100. Weight percent is equal to 10 by 10 plus 40 into 100 is equal to 10 by 50 into 100 is equal to 20%. 2 grams of potassium sulfate was dissolved in 12.5 ml of water. On cooling, the first crystals appeared at 60 degrees Celsius. What is the solubility of potassium sulfate in water at 60 degrees Celsius? Solution: 12.5 ml of water weighs 12.5 grams. In 12.5 grams of water, amount of potassium sulfate dissolved is 2 grams. In 1 gram of water, amount of potassium sulfate dissolved is 2 by 12.5 grams. Hence, in the 100 grams of water, amount of potassium sulfate dissolved is 2 into 100 by 12.5 is equal to 16 grams. The solubility of potassium sulfate in water at 60 degrees Celsius is 16 grams. 50 grams of saturated solution of NaCl at 30 degrees Celsius is evaporated to dryness when 13.2 grams of dry NaCl was obtained. Find the solubility of NaCl at 30 degrees Celsius in water. Solution: mass of water in solution is equal to 50 minus 13.2 is equal to 36.8 grams. Solubility of NaCl is equal to mass of NaCl by mass of water into 100. Solubility of NaCl is equal to 13.2 by 36.8 into 100 is equal to 36 grams. Therefore, solubility of NaCl is equal to 36 grams approx. An empty evaporating dish weighs 20.0 grams on the addition of saturated solution of NaNO3. The dish weighs 66.0 grams. When evaporated to dryness, the dish with crystal weighs 41.5 grams. Find the solubility of NaNO3 at 20 degrees Celsius. Solution: Weight of saturated solution of NaNO3 is equal to 66.0 minus 20.0 grams is equal to 46.0 grams. Weight of crystals of NaNO3 is equal to 41.5 minus 20.0 grams is equal to 21.5 grams. Weight of water in saturated solution is equal to 46.0 minus 21.5 grams is equal to 24.5 grams. Solubility of NaNO3 is equal to weight of NaNO3 by weight of water into 100. Solubility of NaNO3 is equal to 21.5 by 24.5 into 100 is equal to 87.7 grams. Therefore, solubility of NaNO3 at 20 degrees Celsius is 87.7 grams in 100 grams H2O. In this topic, you have learnt solubility of a solute in a given solvent at a particular temperature is defined as the number of grams of solute necessary to saturate 100 grams of the solvent at that temperature. Concentration of a solution is the amount of solute dissolved in a given amount of solvent. A solution containing less amount of solute is known as dilute solution. A solution containing large amount of solute is known as concentrated solution. 100 ml of water can dissolve 36 grams of NaCl at 25 degrees Celsius to attain saturation. A polar compound is less soluble or insoluble in a non-polar solvent. A polar compound dissolved in a polar solvent. In endothermic process, solubility increases with increase in temperature. In exothermic process, solubility decreases with increase in temperature. Increase in pressure increases the solubility of gases.